power m, L2 is equal to a power n, b power m, c power m, then which of the following is true? Here L1 is n number of a's followed by same number of b's, but c's are m. M may not be equal to n and may be equal to n. So L2, here b's and c's are equal, a's may be different in L2. A power n, b power m and c power m, then which of the following is true? So actually we can have a push down automata for both of these, because we can push a's in the first language, and using a's we can pop, using b's we can pop a's, and c's can be bypassed. In the second language we can bypass a's, we can push b's into stack, and using c's we can pop b's. So both can be recognized. So there is a grammar exists for both language L1 and L2, both are context free languages. But if you take the intersection of these two, L1 intersection L2 means if n is equal to m, then only both will be common. So a's, b's, c's all must be equal. It will become a power n, b power n, c power n, such that n starts with any value, some 0 or 1, whatever it is. So n number of a's followed by n number of b's followed by same number of c's. So that is what intersection. We can't have a push down automata for this, because it is not a context free. So L1 and L2 both are individually context free, but L1 intersection L2 is not a context free. That statement is correct. That statement is given in option B. L1 and L2 are context free, but L1 intersection L2 is not a context free, because whose intersection is when n is equal to m. That means a's, b's, c's, all three must be equal. Three counts we can't maintain equally, and push down automata cannot recognize it. When DFA accepts the set of all strings over a comma b, that actually the DFA here, this is the final state. What is the minimum string accepted here? BB. Minimum string accepted is BB. So let us take the option A, contains the substring BB. Substring BB means, so you should accept BBA also. BBA contains substring BB. So from the starting state, BBA is going to again starting state. It is not going to final state. So that is why, so substring is wrong. So begin with BB. Even if you begin with BB, we must have accepted a string. BBAB also must accept. It is beginning with BB. BBAB is not accepted. So that's why option B is also wrong. So end with BB. Let us see option D. End with B. Single B must accept if it is end with B. Single B must accept, but single B not accepted. So option D is also wrong. So the correct option is end with BB. Any string end with BB will be accepted. Option C is correct.
Here a schedule is given and we need to identify whether it is conflict serializable or not. And if it is conflict serializable, we also need to identify the equivalent serial schedule. So for that, first of all we need to know what is conflict serializable schedule. The given schedule is conflict serializable if we can obtain one of the serial schedules from that schedule by interchanging the non-conflicting operations. Before that, we need to know what are conflicting and what are non-conflicting operations. The combination of read and write operations on same data item from different transactions are conflicting operations. Let us say for example R1A, W2A and W1A, R2A and W1A, W2A. So these are all conflicting operations. So we should not interchange the order of the conflicting operations. Let us see if we can get the serial schedule from the given schedule. So can we interchange the order of these two read operations? Yes, we can, because these two are not conflicting operations. So we can interchange these two. We can move these read operations above here. And can we move this write operation? No, we can't, because these two are conflicting operations. So we cannot move these write operations before this read operation. So let us check if we can move this read operation before these read operation. We can move these read operations before these read operations, because these two are non-conflicting operations and these two are also non-conflicting operations. So the equivalent serial schedule can be read A and read B from T1, and from T2 read A and write A. So the equivalent serial schedule is T1 followed by T2. There is also one more method by which we can find whether the given schedule is conflict serializable or not. First of all, we need to draw a graph which is called precedence graph for the given schedule. In the precedence graph, the nodes will be transactions. Here T1 and T2 are transactions. Here in precedence graph, the order of the conflicting operations are represented by directed edges. So here the conflicting operations are read A from transaction T1 and write A from transaction T2. So the order of these operations should not be changed in the equivalent serial schedule. So there will be edge from T1 to T2. So this is the only edge. This is the only set of conflicting operations, and this is the only edge in the precedence graph. If there are no cycles in the precedence graph, then that schedule is conflict serializable. Here there are no cycles in the precedence graph. Hence the given schedule is conflict serializable, and the equivalent serial schedule would be T1 followed by T2. Hence the correct option is A, conflict serializable with the sequence T1 followed by T2.